good morning. Again, back together. We're going to start with a quick review from the last module, which was 30 yesterday. Contents here, we got it. So yesterday you all got a quick introduction, a short introduction to what we did. Queries and lists was the topic yesterday. So after the second module 20 of drawing things and placing things on a document, you also were introduced in how you could go through the database and get information in table forms, either in queries or in lists. And then now you know the difference between queries and lists, and the advantages of queries compared to lists, and the different usages. Then we went on, we looked at some examples, we looked at the PED, how that's sort of like an intelligent one with some calculations in the background. We also looked at data sheets, how the data sheets are actually always below the actual object that they're documenting in that sense. And then we looked at inheriting, how there are different ways of inheriting things within COMOS. We looked at a couple of examples, and then we looked at some sub-objects and different examples of sub-objects. We went into looking at the visualization. So there's lots of different examples of how we can visualize things with the colors on a PNID. And keep that in mind, it's just for you, for one-off, your session as soon as you close your COMOS, and all of that information, or all those settings for visualization are done. What else did we do? Introduction into interfaces. There are different types of interfaces, the big ones, the PIFs and the CIFs, and there's also then the simple ones, which are just basically graphics on a PNID. Then what else did we do? We looked at sort of some special functionalities in COMOS with changing the font size on a PNID. Then we looked into some of the searching functions in COMOS, some of the searching functions that are standard with COMOS, and also the ones that we have developed on our own. And then we went into the plugins. A lot of the plugins that we looked at are actually no longer valid for the valid projects. Obviously, if you're working in a very old project, or if you're working in the service department, then you have to be aware of the different old plugins because they have old setups, old structures. So we looked at description definer, cleaner, numbering tool, that's for non-KKS. And then the typical changer, the typical tool in order to change out typicals. So then you got your little introduction into what are typicals, right? So typicals are these standardization of instruments, right? Whether it's a control instrument for a valve or a motor, or it's heaters. The EMs are also in there. So those are a lot of heaters. Trace heating is always standardized as well. We looked at that. Exchange typical. We also looked at the idea of any object. So if you took a pump, right, you could go and navigate to it. You look at general, and you could change that pump out to another pump, right? From an example from a piston to a centrifugal pump. And that's important because today you'll need to know how to do that. You'll be inserting typicals with a certain valve, and then you have to change that valve out to another valve. Then we looked at the crawler. That's a pretty neat little tool, especially if you're looking for objects in the library. It might be helpful. And then we looked at the data exchange. Unfortunately, it didn't work too well yesterday. Sorry about that. But basically the idea of extracting data. The data is being saved as an Excel file in the Navigator, in the COMOS project, so you can always go back to it. What did I send to what supplier at what point in time? And then you send it off to the supplier with Pierce usually, and then when it comes back, you can use the same plugin to re-import it. And then we went through those steps theoretically, how that would work and how that information come back, and the different checks, right? So, on one side, you've got that Excel sheet with macros in it to visualize with the yellow, green, red, symbolizing what happened to that Excel sheet while it was at the supplier. And keep that in mind. You remember when we did that Excel export as well yesterday, that cover sheet, sort of the rules about importing and exporting with COMOS. It's very important that the supplier that you're dealing with is very aware of this, because if he starts sorting, right? There's a lot of metadata in those Excel sheets. So the metadata that allows it to be re-imported. If he starts sorting that and messing those data up, then you can no longer import that data. So basically, the only thing you can do is send them that Excel file that you extracted at that point again, and you can do the work again. So you have to be very clear with your suppliers. But that's mostly done by the people in CSP, Rolly Holler and his group. And if they're experts in it, if you need some support in that, the first time you do it, you definitely find somebody that can guide you through that. So we did then basically the whole idea of exporting and importing again, because it's basically the same topic, but without the data exchange. So you can always take an Excel sheet, export it, and then re-import some data again. But again, that does need some expertise and some experience. Good. Then the whole, I think that was all done. And then we looked at the automatic description definition, or define, basically how that works. It works pretty good for most of those objects except for the signals. Signals are the only ones that have to be done manually, where the description has to be done manually. Because we did it. So if you guys have a super fantastic idea how we can do that, then please just step up and talk to your local administrator and see if you can convince him that it's a good idea. Okay. Good. We looked at the colors, access rights, and stuff like that at the end. Any questions to what we did yesterday? Because today we're going to move on, basically. We're going to do a little bit, basically our focus today is on EIC. So who's EIC, right? You're EIC, so the only ones. The document was prepared by Nico Trachling. He's an electrical engineer in our electrical department. He's got a lot of experience as well with commissioning, and he actually sort of redesigned a lot of the way we do our instrumentation. So as much as possible with the limitations of our structure that we have now. So basically, it's important that when you're working, you remember the whole standardization is very important for us. And if you look here, we just have two examples here. On the left-hand side, you see a typical analog instrument, and you see on the top here, that's the way it would be shown on a PNID, right? So you'll have at the top here, you have your pressure differential transmitter indicator. Here you have your pressure differential indicator, but in the control room. And then here, this would be an alarm load. So the transmitter is, in this case, it's here at the top. And if you see, this would be basically this green one here, okay? So this is the way, the structure is very important, because if it's not structured this way, then all of those queries that we have predefined will not work. So here you got this first main object, right? And everything is below it, so it's moved in, indented one step, meaning that these are all sub-objects. So this is the main object. So this 100, this green one, pressure, is the main object. And you see that this one has this analog input signal, right? So this is a signal, usually a 4 to 20 milliampere signal, which is going to the control room, right? So it's an input from the perspective of the control room. It's coming into the control room. Okay, so here you see on the left-hand side the analog signal or instrument that I was talking about. And we're just talking about the three bubbles on the left-hand side. And now we're just going through the top one, right? The PDTI is the transmitter. That's the green one, the 100. And that is the main function in COMOS, in the database. And below it, you have the signal, right? That signal, the analog signal, going to the control room. Now, this signal is basically all you really need in this case, because everything else, let's say if you're having an alarm here, for instance, this alarm, this is actually artificially programmed in the DCS, right? So what we're doing though is in COMOS we have to make a sort of like a dummy signal, if you can call it. We call this a software signal, in order to define what level, at what point will that alarm be sound, right? At what point will that alarm be defined? So you have to define it somewhere in the database, so we have to have a signal in COMOS. Okay. The same thing here. We also want to have an indicator somewhere, so we have to have a signal, right? So these signals have to be placed somewhere. They have to be programmed, right? Because using these signals, then we're going to do those FTSs that we talked about earlier. And that's very important that they're available and that those values are there, because that's the document that the programmer for the DCS is going to have in his hand when he's doing the program. Okay. In addition, you have this 51 device here for measurements. This is for cable block diagrams. Okay. We actually go a step further now with COMOS. In the last couple of years, we've developed this. So we're actually doing the cabling. And in order to do the cabling, we need this object, number 51. So you don't really have to do anything about it with it, but you have to just don't delete it. Make sure it's still there, right? So that's the reason that this is here. Okay?
Normally it's always there. So
yeah.
But if I choose a PI instead of a PDIP, so only just a manometer,
yeah,
it's not going to be there.
Probably not. No. No. I'm not totally familiar with all of the templates that we have, but it would make totally much sense because you don't have to cable it anymore. Yeah. So this is basically a typical example of an instrument, an analog instrument. You have the main function, which is green, and then you have all these different ones. So the ones, for instance, this PDI, this would be this one here, right? This blue one. And the PDAL would be the 002, like that. And then below the 002, you also have an alarm. Okay, so it's important to understand the structure. Main, one level down, one level down, one level down, and then below these sub-functions, which are these two, you have the two signals. Okay, clear enough? It's important. This is the way you'll see it in the navigator, right? So when you navigate to it and you open it up, it should sort of say, okay, everything is okay, and making sense. And you don't want to be doing too much in here. We're going to do some examples, because sometimes you have to make changes, and I'll just make an example of how that would work. Now, on the right-hand side, you have a binary signal, which is a little simpler. You see here as well, you just have the level switch at the top here, the 301, and below it you have a sub-function, which would be this alarm high, right here. And you have, obviously, this software signal here. Not really sure about this one. For me, it doesn't make that much sense, because here you have a switch high, right, which would be this one. But this is binary. And then I'm not sure why this would be here. Well, makes sense to me. Does that make sense to you, Toto? Normally it's just an on-off switch, binary, right? So you'd have two signals, and they would be defined as such. You just have a set point, basically, each. So I think it's only to show the symbol that it is. Yeah, so I'm going to talk to
Is the alarm just to then show an alarm in the control room?
Yeah, it looks that way.
The first one isn't indicating anything, it's just actually doing the switching.
This is doing the switching, and then this is maybe
just indicating the
okay, so then you're saying the switch would go to the control room, binary, and then you would actually visualize it. Yeah, okay, that could be right.
That's how I understand it.
Yeah, okay. Okay, good. Thank you. So those are typical examples. And now, obviously, when you look into the base objects, you will find this section here, this pink and red objects. These are the instruments. And they, theoretically, you could take them and you could create your own little Christmas tree on the PNID, with different main functions, sub-functions, signals, and stuff like that. But it takes a long time to get into it and to be knowledgeable enough to do that efficiently and correctly. So that's why, as we always do, we standardize it. And we're using copy-paste technology here just to keep using standardized instruments. And that way the signals are correct, everything will be proper in all the different lists and stuff, and even with the documents that are below everything's there, right? So standardization is very important. So I wouldn't recommend using this, but theoretically, that's how we started, like 20 years ago. We started doing it in COMOS. We had to start from scratch and had to build things, and then say, well, this is a lot of work and, a lot of training. And so what we've done recently in the last, about 5 years ago, is we said, well, this functional information that's in the bubble, at the top of the bubble, we said, we're going to automate this, because up until 5 years ago, it wasn't single source. So actually the signal was there with information about the function, and the bubble was there. And you had to actually two spots in the database that wasn't totally correct. So we did this. It was quite difficult. And the way we did it is by basically, if you look at this one here, you have this is a switch, and here is your analog signal. And so basically, depending on what type of analog signal you insert, and there's a huge library of signals that you can insert, then the text on the bubble will be different, right? So whether it's pressure, temperature, and so on. And so that's easy enough to understand. And then you can actually insert other information. For instance, what was a tricky part was this differential measurements, right? When you're doing differential pressure measurements, then we didn't have a signal or anything underneath it, so we had to actually do a check mark, right? So by clicking on this check mark, this D will appear here, right? And there's also some, so basically, you see this little auto instrument function from the signal. So this is what's being calculated, and then it's being pushed up into here again, right? Exactly. So we're going to do some examples, and then it'll be a bit clearer, but I'm just letting you know like how it's structured in the database in order to get this information out. Right? Okay. And here again, you see the subfunctions, right? So this is the information that you're getting from the alarms that you've inserted below it, right? And same thing here, and instruments as well. Good. So the thing is maybe it's better if I just show you an example, and then we can go through it that way. It's probably the easiest. So let's take a look. If I can find my D1. So I'm going to go to the templates. I'm going to the PNID templates, and then I'm going to open up this one here. Stefan has it open, but it's not a problem. I can open it up with read only. So, and if I were to take a little example, for instance, so a temperature measurement, I can just grab it like this. And then I can, it's still loading, that's why it's a bit slow. And then I just click on the right mouse button and say copy. And then I can go back here to my drawing. And then I could insert it like this. It's not a very good example like this, but I'm just going to do that. Okay. Here there's a pipe. So I'll take this pipe. I'm just going to stretch it down here somewhere. So. Okay. So I'm just going to, because I don't really know where I am as far as the KCAS structure is concerned, so I'm just going to navigate into the tree, and then I'm going to assign, as we learned a couple of days ago, and then I'm going to just grab the 10 and drag and drop it on here. And this way all the objects are now in the structure. Okay, so they have, and they all have one KCAS number, as you see. Also from the colors, right? This light one is the main one. That's the. So if I navigate to it, you'll also see the structure in the database, and you'll see it here. So this should sort of ring a bell to what I just explained to you, right? So this is your structure. You got your main function, and these are your sub functions, and that is your analog signal. So that's the main signal. Without that, the whole thing doesn't work. And then everything else below it is basically, these are the signals here. So here you go. You copy paste this, and this is working fine. But now you realize, I've got an alarm which I don't really need this alarm here. Okay, so that's easy enough. I can just delete it, right? By deleting object. So that's easy. Deleting is no problem. You don't have to think about it too much. And when you delete object, you're deleting the subfunction and you're deleting the signal. So that means everything's gone. So even in the FOOPs and in all the different lists and everything, it's completely gone, right? You even saw it disappear here. So what then? The problem is if you have to add one, it's a little more difficult. So this is how you do it. You can click on the main object right here, and you can say new, and then you can say subfunction. Right, so I could add up here. Well, it's not really what I wanted to do, but with the little stretchy dots, but that's interesting anyway. So now I added a sub-function, but as you see, there is no information in it because there's no signal below it. So that's the next step, is to add a signal. And like I showed you yesterday, adding signals here are limited. You see, as soon as you go 2 steps, it doesn't go down. So that's a bit of a drawback in Comos. You have to actually navigate to the object here in Comos. So here you can say new, and then you can go to software signals because this is a software signal that we're looking for. And then basically we could say, well, what do we want to insert? Okay, and we could say, well, let's go to an alarm, and let's say it's an alarm high, for instance, or 3 high, or whatever. So this one. And so as soon as I added that into it, so now you see that this signal that I added into this subfunction 007 is now appearing here. Okay? So basically, you're already at a good stage. That means that the signal information will be there, the standard signal information will be there, and then you can change the shape of the bubble accordingly. So you could say it's control room from DCS, and control room, DCS, and then it changes its shapes accordingly. Okay, so that's basically what you'd have to, a minimum of what you'd have to do if you were to insert a new subfunction into an existing instrument that you have. Okay? So, simple enough. If I switch back to the document, basically that's what we did, right? So we started off here by inserting, creating a function, a subfunction in Comos, right? And then we added the KCAS number. And then, so here's an exercise that we're doing. Create the following instrument starters. Now, I wouldn't recommend doing this. Take too much time. But here, what you can do is see if you can copy this one. I think it's the same one that I use as an example. And then add the function alarm 3. So add an additional function to this. So leave it the way it is. You don't have to delete anything. And then you just add another subfunction, and then you add an alarmed 3H. Right? So for the alarm high. Right? Okay. So that would be a little example that you could do now. Is everybody good with that, or do you have to explain anything anymore? No. Okay. Go for it. I'll be walking around and giving you a hand afterwards. So, is everybody good, or do you need more time? All good? Everybody was able to insert a subfunction, it was a signal, and change the way it appears on the P90. Okay, very good. So, there's a couple of things I also want to explain. Maybe I should. So, there's one function I haven't showed yet that always sort of pops up as a common need, and that is basically sometimes you have to export a drawing to a different format. Obviously, creating a PDF file is not a problem. I think we looked at it. If I wanted to print this file, we looked at that already with the PDF exchanger on the Citrix server. It's a little bit different than locally, right? On the Citrix server, you have to use this PDF this PDF Exchange printer in order to make a PDF file, right? So it's a little bit different on your local computer. It will be using Nitro or PDF. Yeah, Nitro. So, but sometimes the customer or the consultant or whoever, a partner, needs also another format, right? And this is also possible. So you could actually go on any drawing like this and you could say export and export to DXF and DWG, which is like an AutoCAD format or a transfer format. And so here all you have to do is decide, okay, what drive, right? What I usually do is use the drive P, which is our pool, as we always say it. In Citrix, if this message pops up, you just have to say permit all access and do not ask again. It's just saying allow me to access a drive, right? And using P is, everybody has a P drive. If you don't, you can actually add your own using new. It's very totally open drive. It's like a pool, and
You can actually not tell yourself.
you can't?
No, you need to ask to an administrator.
Okay. Then you have to have a ticket if it's not open, but it should be open, right? Did you have to ask?
I
Or?
have to ask for
Okay. Well, that's not good then. Make a note of that. And the idea of the pool drive is that you can put it in there and it stays in there for at least 30 days. But after, if a file hasn't been touched for 30 days, then it'll be deleted. So it's just a transferring instead of, it's practical. Right? So that's what when I'm doing training like this, I'm always saving everything in my P drive like this, right? So now I can export it, and now I can say what format do I want. Do I want it in DXF format or DWG? Here I'm going to do it in DXF. Here, so now I change basically the path, and now I can also change the format. Right? So I can say actually DWG is but it's a very old DWG format. I don't know if you have experience with AutoCAD. It's I think version 2012 or something like that. But it works fine for data exchange purposes. And then you have a vectorized version of your P&ID, and you could give it to somebody at the end of the project. The DXF is an exchange format. It's very simplified. So it's basically broken down into simple lines, whereas a DWG would have some AutoCAD sort of, let's say, technology in there. So it might have also like polylines and multi-lines and stuff like that from AutoCAD in there. Okay, and then just dump it like that, and then you can also do that for more than one, right? You could actually select a couple here and do the same thing, right mouse button, select. Obviously, it's going to be opening the drawing in the background. It's going to be exporting it. It might take a few minutes to do that. Seems to be. Remember these documents, and below this menu documents, there are a lot of different functionalities in here. This one here is basically a collection of all of the functionality. This one is for printing, right? We saw this already in the modules 10. This is for revisioning, for multi-revisioning, which we looked at earlier. This is for DXF export, which we're just looking at now. So you could actually, basically put the whole project in, search, find 100 P&IDs, and then export from DVG. When you're doing stuff like this, you have to keep in mind that if the document has errors in it, so when you open the document and there's error messages up, like I just got earlier, like inconsistencies, then it's not going to work for you, right? So you have, that's sort of like a prerequisite, is that the document is clean, right? That it opens up without any error messages. So that's generally the case, right? The other stuff here is just to copy the revision file, all right, which is also interesting. So the actual officially revised PDF file, which is going into Pierce, you could take that and you could say, well, copy it into a folder for me. And that's interesting, an interesting functionality too, if you ever want to dump them to anywhere, sort of another file. And this would be printing the current revision file. Might be interesting as well. And this would be print with the revision printer, which would be also basically using the same printer that we're using for revisioning. I wouldn't recommend using that. And if you just click on this one, you see, these are all of the tools, basically for handling documents. Okay, so that might be handy for you. Good. And one more thing that I might not have said. This grid up here. This is also a question going to be coming up in the quiz afterwards, and basically the answer is 2.5 millimeters, right? So the grid that we're using at HZI is 2.5 millimeters, but the grid in some other companies that use Comos could be 4 millimeters or something else, right? That's basically just the way it's set up, like the grid that you see here or something in the tree. Now, another point, I'm not sure if that was mentioned. When you're starting Comos, you start it here like this in the menu. You can also start a Comos Explorer, okay? Why do you have a Comos Explorer? Does anybody know? Well, except for Maria, she knows. Anybody else? You do know, eh?
Actually, I'm not sure what the Commons Explorer is.
Okay, good. That's good. Hey, you learned something from this course. Basically, because Comos is running on Citrix, and if you want to do drag and drop, it's actually necessary that you have a file system. This is the file system, right? Your drives has to be on the same server as your Comos session. Right? So if you go down here, I think this might have been in the first module, and you go to the Citrix receiver and you go to the connection center, then you're going to see all of your sessions that are connected to the Citrix farm. Okay, so here we're on the server 8, and here you've got the Comos session, right? That's the Comos program running, and then everything that you open from Comos. So let's say if you were to open an Excel sheet, then it's going to be open on Citrix, obviously. All right, and if you were to open a Word document, it's going to open up on Citrix as well. And here, for instance, we opened up PDFs, and we open them with Nitro. That's our PDF tool. So these are basically what we call middleware. So everything you double-click via Comos is going to open up another program, and so you see them all here. And now, if I want to drag and drop a document into Comos, into the Navigator, which is possible, then you need to have a Comos Explorer. Okay, so that's the reason. That because you have to be on the same server, so you can't go from one server to another and drag and drop. This doesn't work. You have to be in the same. So your sessions have to be in the same server. Is that clear enough? It's a bit sort of IT techy, but you guys.
So you have access to kind of the documents that you have on your computer, but if you open it via the Comos Explorer, then you're on the same server. You can drag and drop.
Well, yeah, you have access to the drives that you have access to, right? Some of these ones are local ones here, which are on this computer right here, right? You see them here, local disk, and then these ones are just net drives, right? Yeah. So if I were to go to P, for instance, and I go to my drive, I probably have something. I could probably. So normally I would do it. Let's say I want installations, right? So in this trainer here, I could go to documents, and if I wanted to drag and drop something here, I could grab this exercise sheet here, and I could drag and drop it here like this. You can see the plus comes in, and plus is good in this case because you want to have a copy of it, right? And then Comos will, if you look back here, will have a little window popping up saying create a copy or create a reference. And I would recommend having a copy, and then it's going to make a copy into the Comos file system. Okay, and then so now you have this exercise here. Okay, basically. And now if I delete it, and I delete it from the file system, the Comos file system, that's not a problem. Right? But you could actually, what you could also do is the other way around. So you could take a file out of Comos and drag and drop it into another file system, but then again, it has to be a Comos Explorer. Okay, so that's important. But was that not in the viewer module? No, okay, good. That's good. Actually, it should be. Because the viewer, you can do the same thing. So. Oh, no, you can't. Yeah, that's right. Okay. Good, so this is just a couple of things. Now I want to do another example, which is very similar to what we just did, but using the typicals, okay? Because we have very little experience with the typicals so far. So I'm going to open up the template for the typicals, and I'm just going to do one example of how the typicals have been, are being placed. And first of all, you have to find the right one. So let's do something similar to the example that you're going to be doing this afternoon. I think it's up towards this direction. So, yeah, well, we do this one here. So here we got a pneumatic actuator open close with the main valve is depressurized when it's open, and the main valve is de-energized when it's open, unilaterally pressurized with spring return, 3-2 pivot valve with spring return. So this is UV 1.2, right? This is as we define it. I don't know what the difference is between this one and this one. The only difference is, no, that's the same. Yeah. Well, I'm just going to take one, like this, same brilliant copy-paste method. You can go like this, and then you can place it like always using automatically. You can theoretically use the other ones, but these, I would recommend using it just automatically like this, placing it. So now it's not assigned, so we have to do this assigning again. So I'm going to navigate to my structure, figure out where am I. So I'm here, and then just by navigating here, assign, I can choose which objects, and then I'm going to go up to this again, to the 10, and then I can assign these objects. So now everything's been assigned. If you look at it here, and if we, so I got to click out of the assign mode, obviously, and I'm back into the select mode, and now you see this is the main object because it's a little bit brighter, and the other ones are all sub-objects to it. And if I were to navigate to this object here, you see it here below. So the actual object here is this valve, and then you have a membrane actuator, and then you have 2 switches below it. Basically 2 end switches, I guess you can call those, right? And then you also have a few things, like this is the pilot valve, and this is like the regulator for the air, and this is the air supply. These are just instrument air symbols that we have on the drawings, just to say where the instrument air is. Because the instrument air, like I explained one time, I think it was in the second module, where it's just, we don't draw all those pipes on the drawing. I'm not sure. Do you do that in Japan as well? Do you draw the actual pipes for instrument air on the drawing? Or do you just sort of make symbols like that as well?
The PID?
Yeah.
Just a symbol.
Just a symbol, yeah, yeah. And that's how we do it as well.
Field routed.
Yeah, field routed, exactly. That's the term of that. Yeah. You just tell them all these spots, make sure there's air coming to them. I mean, sometimes it's just plastic pipe, and tubing. Okay, good. So that's how typicals are being used. And now that example again, I clicked on it once, right? And you got these different violet colors. And then I click on it one more time, it turns orange. And now I click on it again, and now I have this valve by itself. Okay, so I clicked on it 3 times with the left mouse button. Okay, and now what I can do here is I can look at the properties of this particular valve, and I can change it out. And this is also a little task. So this is a shut-off valve. So I'm going to navigate to the library by going to the object. There, and now I can change it out with, I don't know, whatever, what would make sense in this case. You can change it out with a globe valve. No, I'm not sure. Can you get a pneumatic globe valve? Oh, so I'm just going to change it out like this by dragging and dropping this globe valve here, and you'll see that the path changed, the name changes. So I say, okay, that's fine, And then I take a look, and now I see. And remember how that is when you change out an object like this. It doesn't always change, because if somebody had changed this object on this drawing, so what I have to do here is I have to click on it and say restore original symbol, right? And then it will inherit the information from the newly inserted, right? So now you see, now it's a globe valve, right? So the symbol changed a little bit, so now you change it from a shutoff valve to a globe valve, and so you're doing that's a typical little exercise. Why don't you try to do that? Go into the templates for the typicals, find one you like, copy paste it into your drawing, and then give it a KCAS number and change out the valve like that. Huh? Do that as an example now. So let's continue. There's a couple more things we got to do, and then we can maybe take a break, do the quiz, and then get ready for the exercise this afternoon. So, let's see, where were we? Subfunctions. No. So this was the first exercise we did with the instrument, right? How are you guys doing in Slovakia? Is this working out for you with the copy-paste of the instruments and typicals?
I think everybody else of us did it.
Okay.
Yes.
Good. Good.
Okay.
So now, just want to go through a repetition of the different types of signals. We were looking at signals earlier. We see here you have, these are the main types: analog input, analog output, from the perspective of the DCS, and then you have binary input, binary output, and then you also have software switch, as we call it, when it's like a dummy switch where you're just basically putting in the value, right? Because you're using that to document the logic of the system. And these ones here are used when there is no real signal. This might be used, for instance, if it's an indicator or something like that. So those are the types. That's just a pull-down menu, basically, that's limited to that. Now, when we clicked on the sub-function that we inserted and we wanted to add a signal, then those right mouse buttons or the right mouse clicks, we saw all sorts of different signals. And now, this is sort of a grouping of what those signals are all about. These are switches. These are inputs to the DCS. And what else do you have here below? Here you have alarms, right? And then it's just basically simple enough. You got low, the different types of lows, and you've got highs, different ones, and that's basically it. And then you got these ones here are analog into the SCS. Yeah, I don't really know what that means, but I hope you guys do. Input, output, the different signals. Does anybody understand this? This YE bus signal. For bus, we're going to get to the bus signals afterwards. And then here you have binary outputs as well. From binary outputs from the DCS. I don't know how.
Do you have to shut something down?
Okay.
The interlocks.
Yeah. Oh, with hard interlocks then. Yeah.
No, well, with software.
What if it's
But
binary?
actually it's going to be hardwired. Yeah.
It's going to be hardwired with
Yeah.
binary, right? So okay. So I guess that would be like a safety system or something like that. No, I think mostly it's with a bus system or whatever. So actually, that's the next topic, I think, when we get a little bit further. Oh no, there's logical signals. These signals are used in place below the logical diagram. Okay, we talked about the logical diagram. Like I said, that's a separate module, which takes also another day to go through that. I can't say too much. All I know is that the signals, there are often times that you have signals that are, like you have the signals when you're doing the whole engineering, like in Comos now, we're replacing typicals, instruments, and so on. But there's also signals that are going in between. two different systems, right? And then you would use these ones here, I think, below, and they might be below documents or below, let's say, an artificial node where those signals will be placed. But I think that will be explained a little bit better if you do the FDS training, right? So these are the different types: binary, logical symbols, numerical. I think even within the logical diagram itself, it has signals. So those ones would be below the logical diagram, and then you have a selection out of this catalog here. Bus signals are becoming more and more popular in our plants now. This is an overview of which parts of the plant, so like for the cranes, for instance, and the bottom ash, and all these different areas, and I think it's growing quite rapidly. So this is something that you have to get accustomed to. Respectively, in the copy templates, these are actually being changed out for bus systems, something that is, if it's a standard now, then changing it out. So this would be a typical way you'd have like your cabinet here, and you basically, instead of having heaps and heaps of different signals in here, sub-functions, you would just have one, and then below it you'd have hundreds or thousands of buses.
We don't define the signals in columns.
We can, yeah.
All the let's say all the real signals.
Yeah, okay. That's the idea. Do everything. It's an engineering tool for that purpose. So we can do an example of it. I think, or is there an example coming? Sub-functions and base objects. So why don't we just dive into COMOS here and see if we can find it. So I'm going to go here. First of all, we have to find the instruments, or the functions. Here are the functions I was telling you about, right? So theoretically, if you were to go here, like start from scratch, you could take a level switch like this, and you could place it on a. So that would be it. And from there, you'd have to build it up, and from here you could add a sub-function, right, like that, and then you could add the signals below it, and you could add all the stuff you need, and then you can give it a KCAS number and change the way it looks, and so forth. So, but I wouldn't recommend it. I would always recommend using copy-paste. And here, you got these bus signals, which are pretty new. I think they've only been used for the last couple of years. So here as well, it's quite simple. You can just basically place it like this. You could actually give it a KCAS number by, let's say, inserting it to that structure. So it's going to be called an EK002. And if you look at it in the structure, it's going to look not new, but navigate. So basically nothing spectacular. The only thing which is different is you can say create signals. So this has like a little script in it. You can say how many signals do you need, and then you could say 25 or whatever. Oh, it's maximum 99. I didn't know that. I just saw that. So and then you could, if you open and close it again, you'll see that there's now 25 signals here, and then you could name them accordingly, right? With that, you could use a query, for instance, and you could go through them and give them a name and number, or whatever like that. So then I'm sort of not too familiar with that type of engineering. So that would also be a possibility with these base. There's two different types of bus going to the DCS and coming from the DCS. Yeah, okay, because the signal must not be changed, even when it's transferred across various systems. I don't really follow that, but I hope you guys get some electrical training to help you understand that a little bit better. And otherwise, I'm sure that your working colleagues can explain that too. And I know in AD it's slightly different again. So here you go. These are the standard naming of the signals, like for the actual name of the signal. That's predefined. That's what we just did. So field measurements. Yeah, bus. I'm not too sure about this one here, field measurement center and intelligence system. Okay, intelligence system would be like an autonomous system. So if you had, let's say, like the Roche, like the, what do you call it, the grate. The grate has got these hydraulics controls. You know how the grate is moving like that, and the logic to move that is not in a DCS. It's in a cabinet which is close to the grate, and that logic is an autonomous system, and it's going to work on its own, and then it's only going to give like a signal once in a while to the DCS saying, "Oh, everything's good," and "Oh, I got a problem. My hydraulic pressure's down," or something like that, right? And that, I think that's what he's talking about here, is how the signals are going from an intelligent system to the DCS via bus, right? So then you would insert it using something like this. Okay. That would be sort of an example, I guess. I'm not sure if it's a good example. So, and what else do you have examples here? Transferring to DCS. I don't really see the difference too much. It's going just to, yeah, and from, to and from, yeah. Basically this is the direction. Okay. So, and when you're in the bus, you got a bus signal, then you can look at the tabs, and they'll have information here. It's this what's marked in green, and basically they just want to know some of this, the type of bus that you're using, which Profibus is common here, but depending on the project, of course, depending on the customer and stuff like that, then you have to define this accordingly. And you could obviously do a lot of this information. Like signals, you're working with queries, right? Because there's really hundreds and thousands of them you have to work with them. And this is sort of an explanation of what is to be expected here, right? So you guys can read that. And then you got bus signal queries. Not quite sure about that one. Bus signals for suppliers, bus signals for internal use only. Okay. So these are the queries, like I was saying, to manage these signals. Queries are the best tools around, so I would just recommend using this one. This is these are two that basically Nico is recommending to use for this purpose. Okay. There is a couple of new things we have. Well, new, it's about 2 years old. We have this anti-condensation heating for the motors, because we have these plants we're going to be building in Moscow. It gets pretty cold there, so you got to keep a little heater to keep the motor warm enough that it doesn't condensate. And so this is something that what you're going to be doing if you're on a motor. And basically, all you do is you go to the motor and you turn it on, the anti-condensating heating, and then automatically you'll be having a symbol like this on the PNID. So you don't have to insert it with the normal way with new. We could do an example maybe. It would be here. Maybe you could even do it from here. Can you do it? No. I was thinking it might be up here, but it's not. Yeah. Yeah. And it's here. It would probably be here. So, and if I were to do this, hang on, I'll just pop this down on this side that we can see it while we do it. Then you see how the heater appears automatically. And I think with this one as well, I don't really know what this looks like. Yeah. So, but you can probably. Yeah, you'd have to move this little guy out of here in order to be able to see it. Okay, so that's simple. I mean, what the advantages of this way is you can go through the query with the motor, right? The e-consumer query, you could add these two fields and you could go through, say, well, boom, boom, boom. You can add these subcomponents basically to the motor in a query and you get it done real quick. You could add 100 of them. But you might want to take a look at the PNID afterwards to see if everything's, readable. Okay, and what some other little interesting, basically it's the same thing here. That's the other way, the other version of inserting this. And then when turning it off, it's obviously going to delete the object, right? So if we were to take a look, maybe it's a good idea if we do that. We're going to navigate now to this object. And when we expand it, we see that those two sub-objects have been inserted, right? So it's not just a pull-down menu, it's also an object.
And what's the reason why it's not below new?
Good question. I'm not sure why they chose to do it this way. I think probably because using the queries, because that's a big advantage of that, right? Because I don't know how they would handle it, but I probably have assumed they're going, okay, well, they're going to say, well, all the motors that are outside have to have this, right? So then you can just search and boom, and then you can do it quicker, right? Whereas inserting with the right mouse button, you'd have to do it. It's a lot more work, right?
How would you define the
Layout.
I don't know.
Yeah, but
PIDs, I'm not sure, I don't really know. But
you find after one combos when it's like.
yeah, good question. I don't know. I'm not really, but maybe just from the systems, right? Just by knowing the systems, like let's say the Luva or something like that, that'd be outside, right? So that's how I'd go about it. But I'm not really familiar with that. It's just a hypothetical idea of mine. Yeah. But maybe this will become an attribute, right? All right. Okay. Good. So let's move on. We're pretty much through, I think. We're coming along here. So this is what we saw. Yeah. So read up on this. It's important that you read these documents. And you have also these power supplies. Again, that's just basically a sub thing. That is inserted the normal way with the new inserting power supply. That's like I explained. That's something you have to sort of understand because often they're grouped together, right? You'll have instruments and they'll be powered from one cabinet over here or whatever. And then it's not common to have a power supply for each instrument. It depends on the location, right? So if the instrument's way up high somewhere and it's far away, then it might have to have its own power supply. I don't know. Do you have any examples, Laurent, of this? How this would be handled? Although one thing that I do know is that these power supplies, sometimes what you can do is you can say don't. I think you can say that to all of them. Don't calculate them, basically. So don't put them in the e-consumer list, which means they won't be calculated, right? So theoretically, you could have a power supply just as sort of a reminder that it has to be cabled up, but it won't be actually a power supply as such. So that is theoretically also possible. So let's say if I wanted to, if I go to an instrument, here, like this transmitter, I could say new, and I could add this power supply here. And then if I look at and it's important, this whole idea of inserting below, because by doing so, this has already got the KCAS number, everything's done. So if you go and find something in the base object in the library and drag and drop it on the PNID, then you still have to assign it to a KCAS, or below it. Right? And that usually takes 2 or 3 steps, so that's why it's not recommendable. So I'm just going to take a look at this. So this would be this power supply below this transmitter, right? And I could say, well, don't calculate that. I just want to have that on the drawing that I remember that has to be cabled up. Right? But that being said, maybe it's changed now with the cable blocks drawings. Okay, I don't want to bore you with that. So templates, you know what they are. Below the V templates, right? You got these ones are the normal functions. These are the typicals. Basically, this is just nothing more than what you see there. The whole idea, copy paste. There are examples where this would work differently. So, like for For the heaters, you could theoretically place a heater and then say new and insert the typical directly. But that's the only. I think these two are the only places where that would work. I would recommend just go to the templates, copy paste, and give it a KKS number.
The motors were flexible.
Yeah.
Not all the options are there.
Exactly. Yeah. So I don't know. I think it's safer to do it this way because it doesn't work. There are some limitations of the depth of the structure you can do by inserting over the right mouse button. Okay, and here we got an exercise. Copy a typical from the template on a PNID and assign a KCAS. I think you did that already, right? Okay. So the e-commissioning sheets we already looked at a little bit yesterday, so I don't think I have to explain that too much anymore. No. This is just examples. We looked at this yesterday already. So then you got basically, I think it's the last exercise, is the how can a sub-object be inserted below a main object, an instrument, right? Just write that down in short text. Insert a commissioning sheet below an existing temperature transmitter and print it out. Copy an instrument from the template PID, and place it in another PID assigned to the KCAS number, and open the properties of the signal below a transmitter and enter the value 100 in the set value attribute. Okay. So do that, and then basically we're done for today. And then we can have a coffee break, and then we can do the quiz afterwards, and then we're good to go. So we're back, and basically, I'm going to do that. I just want to go through these exercises because this is basically the next step. The quiz you can do on your own afterwards, and everybody. Ooh, I didn't do that. Well, did I? Everybody's going to get an exercise. You might have noticed in Comos, in the Navigator, there's a new node in there called exercises. Okay, and I'm just going to hand these out, and that way you all have an exercise. For the people in Slovakia, can you hear me? Okay, you guys will be using the exercises 7, 8, and 9. You can just distribute them so everybody works in their own. And here, I'm just going to distribute these.
Tak odmrbačte. 7, 8, 9.
Okay, so this is the exercise. They can be found here in Comos. Not here, but here, these exercises here. Okay, so they're this E1 basically, and there's like 1 to 9, and so when you open it up, each exercise is like a little plant, your own little plant, and it's important when you're working in there, especially with the queries, you only drag your exercise 2 into the query and not somebody else's. Otherwise, you're going to be walking on each other's toes. All right. And so this is the drawing that you're going to get. Basically, you see there's 1, 2, 3, 4, 5 sort of red linings. Those are the areas where you have to do something. And what you have to do is described in this document that I just handed out. Basically, so you open up your little exercise, and then you add the components which are on the drawings that I sent you, or that I gave you, right? So the main thing, that is the main task. That will take the most amount of time. It's just that you're copying and paste some typicals or instruments, and you're reconnecting the piping, and everything has to be nicely done. You don't have to add any sort of, so if you look here, this is the same document that you guys received. This is the overview. So this is like this, you have to add this pump, this motor, and this typical, right? So the whole thing you can copy paste. This instrument here as well, This is a valve with this UV 4.2, right? So this is also something you can insert in here. Here you have to insert a manhole. Here you have to change these valves to close, and basically that's the task at hand, okay? Once that's done, then you can move on. I mean, there's the other, these are basically just zoomed up so you don't ruin your eyes looking at the A3 copy, right? It's just basically close-ups of the same thing. So if we just go through the next, there's just like 9 little tasks. First is to actually add all the components that are marked in the red lining, right? So the ones I just showed you. And then to check the document and repair it. One point about checking and repairing, that's not what I wanted to do. But when you're repairing or checking the document, there's one tip I didn't give you yet. So you say check document like this. This thing will pop up like this, right? And when you're closing it down here below at the status window, so you would expect that the closed tab would be down here, right? But it's actually up at the top. You see it at the very top there? So then you have to take your mouse and go to the top to actually close that tab. It's a sort of a little feature. Okay, and once that's done, and just do that once because that is a bit of a difficult task. Okay, so now if we go back again, here we go. Okay, so check the document, and then the cleaner query. Oh yeah, I don't think I ever showed the cleaner query, did I? I better do that. Otherwise it'll be. So the cleaner query works like this. It can be found here below the queries. It's at the very bottom, this QZ. And if you double click on this query, you see it here. And then you could take, let's say, exercise number 2 as a start object, whoever has that. And I could run this one. And then if there are any objects that are not placed on it, then they would appear here. Obviously here now they're nice and clean because it's brand new. It's part of the. So what I could do here is I could take a part of, let's say, line 0 into here, and I'm just going to search. And basically, the clean query is just going to say, well, are there any objects here that are in the tree, in the navigator tree, but are not placed on an object? Or is there anything like empty structures as well, right? So, but I'm actually having a hard time to find any dead bodies, as we call them. Now I'm going to scan the whole line 0 to see if there's any sort of objects that are not quite proper. So here they are. So here you see there are some empty folders. Right, so a KCAS structure which is empty, and so you can delete that. And there are also some objects. So main object is not placed. That means that this pipe here, right, which is, let's take a look at it. We can navigate to it. It's probably something I just did. And basically what you can do now is you can just go like this, and you can say Control A to mark all of these objects, and you can delete them. Okay, unless you see something, oh, that's interesting, like it's an object that should still be around, or why is that not placed? But generally speaking, if it's not placed on a PNID, it's like an object in the tree which is not doesn't have. I mean, if it's not on a PNID document, then it's not going to appear on the queries as well. So then you can delete it like that as well. And that's something what you can do, and you have to do this, unfortunately, quite a few times. Especially if there's empty folders like this. In this case, it's actually not too bad, just a couple of times, until there are no more empty folders and no more objects. So now it's completely clean. So line 0 is completely clean now.
How did you open the...
Yeah, that's below here, the queries. So here, and then this one here. It's underneath the cleaner queries. Here are the instructions if you want to read up on it for later use, and this is actually the query. So that's a way. So by checking the document, You're making sure that everything is consistent to the database. And by cleaning the database, you know that everything is placed properly. Okay? And those two methods, you have very consistent data. Right? So that is cool. And remember, when you're doing the exercise, to always save your document. And once that's done, you go move on to this one here. You're going to use the queries to fill out valve lists, right? So basically what you can do is start a valve list. You can find one of those valve lists that we were working with yesterday, and then to add some information in there. There won't be much to do, but you can add 2 or 3 columns with some information. The same thing with the e-consumer. You won't have very many e-consumers, just to let you know, but you'll have, and you can just fill those out. So you can fill it out with that method I told you with the standard motors, for instance. So once that's done, then basically print it out. You can print it out to your desktop. And keep in mind with the Citrix, right? Citrix, you have your own desktop. It's not the same desktop as your local computer. Okay, so just keep that sort of headset. So you can print it out as a PDF, for instance, with the PDF Exchange. And then you can export your queries to an Excel file, also on your desktop. And then you can make a revision at the end with 1.0 of your drawing with these 3 initials. Okay? And that's it. And so as soon as you're done, just let me know, and I'll come and take a look to make sure this is all done properly. And then you're done for the day. So that, theoretically, you could do this in about, let's say, 2 hours on average, right? So plus or minus, maybe 3 or whatever. But so you have time now. It's 11 o'clock. You can do the quiz, take a break. I'm going to go for lunch in between. I'll be back here around 1 o'clock. Is that okay? You guys good at working on your own like that? Okay, good.